last, we can do the daily integral from dailyintegral.com. Let's do the medium one, just looking at it. E squared. Oh, that is ugly looking. What is this integral? Looks like we already have a candidate for the u sub. Oh, and multiplied by 1 over x. Now that's something. Oh, that does not pull. There we go. My first thought is maybe we can use as a u sub something like this. The issue is the du doesn't really match what we have here, because the du is going to be it's going to be a u times, oh, it's ugly, -1 log squared x plus 1 minus 2 times 2 log x over x dx. That doesn't look like anything we have here. Oh, okay, yeah. This is not quite a speed run anymore, is it? I don't like the denominator we have. I should emphasize that this is an exponent. Well, just for funsies, let's expand out that. I'll have a 36, 12 log x, log squared plus 1. Whatever. Well, the fact that we have this 1 over the x there, I'll use that for u sub. So instead of this candidate, we're going to use u is log x. So that means our integral I is the same as the log of x, so it's 2 to 4 du. It will be e to the u squared plus 1, a Gaussian. Oh, no, it's not a Gaussian. Forgot the exponent. Maybe I can factor something out of the denominator. Anyway, we'll just write it. Not sure what form is the most helpful. maybe let's do a shift. Instead of like 2 to 4, I want to go from 0 to 2. Will that save us anything? Because this would be like a, say u equal, well, let's say y equals u minus 2. So 6, this right here. Four minus y, and then u squared would be y squared plus 4y plus 1. Oh, I'm struggling with this guy. Maybe there's some trick I'm forgetting, like King's rule or however that went. King's rule, well, I don't even remember. It was something like an integral a to b of f of x, same thing as integral a to b f of a plus b minus x. I think that was King's rule. Oh, that might be nice for 6 minus u, because if we have u going to 6 minus u, with King's rule right here, and we get the 6 canceling there, but then we still end up with having a u squared going to 6 minus u quantity squared. So we need some other algebra before we apply a rule like that. Maybe some sort of series expansion when we multiply things out. So right now, instead of doing King's rule shenanigans, let's use this y sub. So I is going to be integral 0 to 2 dy of e to the y plus 2 squared plus 1 reciprocal over the same plus your 4 minus y squared plus 1, and then the algebra that you could spot pretty early anyway is to multiply out this guy. So multiply by 1. so our numerator has nothing. Our denominator will be 1 plus exponential function of that's no reciprocal there on the red. It would be y plus 2 y squared plus 1 over 4 minus y squared plus 1. Okay. If I want to see if we can use like the classic geometric sum to expand the denominator or the integrand. Use this trick in quantum integrals for my Dirac and such. The issue is we need a quantity that is less than 1 always. And that means we need the quantity to be a negative. The issue is that argument of the exponential right there is always positive. So we multiply the whole thing by, we could multiply by the reciprocal of the exponent on the numerator and denominator, so that we have an integral of e to some stuff and then 1 plus e to some negative stuff, and that would allow us to do a series. Let's do the geometric series. Yeah. Well, I don't think this is going to be the trick. I don't think that's going to lead us in a helpful direction. My ideas are to, right now, are to do polynomial division and see what happens. Maybe u equals the argument of exponential. Just boldly do that. The structure of this integral, though, it's very intentional. It looks like it's asking for us to notice a trick. Let's do the polynomial division first, just to see if we can learn anything. So what we specifically have is y squared plus 4y plus 5. That is going to be divided by y squared minus 8y y plus 17. Yeah, we of course have a remainder. Maybe from there you can do, what do you call, when partial fractions really give us anything, it would let us write the exponential we got here right now as e, we have x of the argument, it's going to be the same thing as e times the exponential of 12 times, and it could be two linear denominators going on. I don't see us getting much from that. How do people do this in 5 minutes? Let's be brave. Okay, let us be brave. Okay, so we did our polynomial division, so we can rewrite our integral like this guy. Now let's briefly set, I'm just going to reuse the same symbol u for substitution. This is an awful looking substitution. Let's put it all in the numerator, single fraction. This u sub doesn't seem like it's going to go anywhere. I mean, I could have identified already here something that looks like EU again. And I could multiply and divide here by y minus 1 to get another u. But solving for y in that mess is a little ugly because it's quadratic. Okay, I think I attempted this long enough. I'm going to look at a hint. Yeah, first hint is to try to use a logarithmic sub. I did that. Yeah, and the second hint is exactly King's rule. Okay, so I did have a sense of the ideas behind the person who made this. So let's kind of ignore what I did beyond mentioning King's rule. Let's try that again. So use King's rule here. This is our integral. And we're going to use King's rule right here. So for our case, we're going to have all instances of u going to 4 plus 2 minus u. So our integral is going to be u is 2, so it goes from 4 to 2. Negative du. So that negative lets us interchange those bounds real quick. We're going to have e to the 6 minus u squared plus 1, reciprocal, a repeat, and then we're going to have e to the u squared plus 1. Oh, that's the idea. Notice that the denominator is unchanged, right? So we have two distinct expressions for the integral. This one and this one. We can add them together. So 2 times the integral is going to be the sum of these two guys. Notice that the integration range is the same for both. They have the same denominators. So we nicely get the integral 2 to 4 du. Yeah, I feel a little silly not immediately trying King's rule, but you gotta try stuff and fail. And I'm pretty sure you can all see what's about to happen here. The numerator and denominator are identical. And that means we're allowed to cancel them out because they're always positive. Or I guess all that really matters is the denominator is never 0 in this interval. So we get the integral from 2 to 4 du. which is of course 2. So this means our original integral is 1. And let's input that into the website. Wait, there we go. Yep, that was the integral. Okay, I guess not a lot of educational value in this one, but it was an attempt. Have some fun doing intervals, everyone. It doesn't need to be perfect.